I want to solve another buffer calculation, but this time what they do is they give us different volume and different concentration. So ethanoic acid, you have 30 cm cube, and sodium ethanoate, you have 40 cm cube of different concentration. Then again, it's a buffer of ethanoic acid, so I write ethanoic acid dissociation. Same equation works for buffer, plus H2O dissociates partially to give me ethanoate plus hydronium, H3O plus, aqueous. Now I'm going to just apply Henderson Hasselbach. So pH of a buffer should equal its pKa plus log of concentration of salt, which is your conjugate base. So this is conjugate base, but it also comes from your salt. So don't forget, divided by concentration of your acid. pKa of ethanoic acid, you will look it up, is 4.75, rather 4.76, sorry, plus log of concentration of salt over concentration of acid. Now let's see what we are going to do to find concentrations, because we have different volume. So what I'm going to do is find moles of acid first. Moles of acid is simply concentration of the acid times its volume. So I have 1 mole per decimeter cube multiplied by its volume, which is 0.030 decimeter cube. I divided by 1,000. If you do this, you get 0.030 moles of CH3COOH. I'll do the same treatment for the salt. So moles of salt is concentration of the salt times volume, which is 1.10 mole per decimeter cube, multiplied by 40 cm cube, which is 0.04 decimeter cube. When we do this, we are going to get 0.044 moles of sodium ethanoate. You can just write ethanoate. It's the same concept. Now I'm going to plug it in. pH equals pKa, which was 4.76, plus log of, now concentration is moles divided by total volume. So for the salt I have 0.044 moles divided, the total volume is 30 plus 40, which is 70 cm cube, or 0.07 decimeter cube. So this is my concentration of the salt. Now concentration of the acid is moles of the acid, which is 0.030 divided by the total volume, 0.070. But if you note, the volume cancel each other out, or you can just include it. And if you do that, if you do it gently, you will get pH equals 4.93. Now one other thing I want you to note here, and on the next slide I talk about it, is if you dilute this solution, since the total volume is going to be always uniquely constant, your pH doesn't change. So at this stage, maybe you want to remember dilution does not change your pH, but eventually it lowers your buffer capacity, the amount of the acid and the base that you can neutralize and sort of maintain your pH. One variable that definitely changes the buffer pH is temperature, because temperature will change both Ka and Kb, are function of temperature. And if that's the case, if they change your pH and pOH changes, because pH was pKa plus log of concentration, initial concentration of salt over acid, and for basic buffer you had pOH equals pKb plus log of salt over base. So if you change the temperature, you will change pH and pOH respectively. but dilution does not change pH.